Okay, today I'm going to be talking about character customization using UMG and Unreal Engine 4 and 2D animation blend spaces, using 2D blend spaces. So you can have speed and direction and use animations that can use speed and direction. Previously I was just using the 1D animation to make the fish swim, to blend it from idle to swimming faster. I'm going to first talk a little bit about something else. A few variables that I had to introduce to create some cool camera effects, which I'll show in a second here. One of the camera effects are zooming in and out, which isn't all that fancy, but it is pretty cool. And then I also fixed the fish so that it actually detects when you're accelerating. You're moving the pawn, you're pitching the pawn, but when it's detected that you're no longer accelerating, he's actually using the mouse look to look to match the camera's rotation and look with the head where the camera's pointing. So you can see the eyes there following the camera. But that it only does that if it doesn't detect acceleration. I'm going to show how I did that in a second. Just quickly want to talk about this look camera here and just general camera animations. So looking at my C++ project, I just introduced a few variables here: camera boom, yaw, offset, and length. And I use these in the tick function of the actor, because all my actors are tick enabled. And then what I do is, if any of those values are set, if they contain values, so if the camera boom yaw is set, it would mean I want the camera to yaw to a specific, with a specific rotation. So how I do that is just by simply linearly interpolating to that value. But what I do is I get the actor rotation of the current of the character. I zero out the pitch, and then so I force the pitch to be always, the character to always be level when I start this animation. So it'll only do that once. And then I get the relative rotation of the camera boom. Now the camera boom is this guy right here. There's a boom. That's basically almost like a spring arm or whatever that connects the camera to the character. So as this boom rotates, the camera's always looking at the character, so you can orbit around. The thing that's orbiting here is actually not the camera itself, but the boom. You're actually manipulating the boom. And then using some values here, set use pawn control rotation must be true on the camera boom for this stuff to work. So once I've got the relative rotation of the camera boom, I create a new rotator, providing it with a yaw where I want it to yaw to, or rotate to. I check if it's nearly equal. There's another function you can use to do this as well. You can just use the equals function with the little epsilon value, and I'm just using this. And then I'm getting the camera boom rotation in world space. So that was the relative rotation. I'm getting the rotation in world space. If it's close enough, then I zero out the roll, and I just set the controller's rotation to match the camera boom's rotation, because if I don't do that, the camera will just simply jump back, because my camera is set to use the controller rotation. Use controller rotation is set for pitch and roll. On yaw it's disabled. And if it wasn't close enough, it will linearly interpolate towards that rotation, that local rotation, and just set that relative rotation. And if the pawn control rotation is true on the camera boom, I set it to false. And then here, when it's close enough, I set it back to true, so that the boom will use the controller rotation. Then there's the offset. I can also interpolate the location of the camera, which I do for the customization screen, which I'll show in a second. That's very similar. I get the relative location of the camera boom, and then I use here vector interp to. So this linearly interpolates a vector to another vector, taking the relative location and then the boom offset where I wanted to interpolate to over 3 seconds, and then I set that as the relative location of the camera boom. So that will actually move. You can pan the camera like that, but it will always. I think it will still look at the fish, the target. And then here I simply detect if it's close enough to the offset. I just simply stop interpolating, set the offset to 0. And this here I introduced another variable here, because previously what was happening is this pitching up and down was happening even when I was not accelerating, and I didn't want that. So now that's not happening anymore. You can see now the head is going when I stop providing input, and as I give input, the whole character moves up and down, and that's for controlling the character more easily. So I wanted the character to not move completely up and down when no inputs provided, because I want to use the look at of the camera for the head. So that the fish is going to try and look where you're looking. So if I'm looking behind me, he's going to try and look behind him too. And then the values are clamped, so it doesn't break the skeleton or the rig. Okay. So the way I did that is I introduced another variable called input pressed. Well, this doesn't care about any other action or things like that, just acceleration input or movement input. So if the character has any movement, then that's considered to be true. So if I'm moving in any direction, that will be true. And then all I'm doing here is making sure that the use controller rotation pitch is set to false if I'm not using this variable. So then the character will no longer pitch up and down. I'm just going to show how I did the controller look, the character's fish look at, using that variable in the animation blueprint for that character. There's a function here, track the controller look at, and this is just part of the normal update event, and it just does a few things, but I only want to do this for if it's the player controller, so that's what these checks here are for. And he must not have a focal character, otherwise he's going to be trying to look at the focal character and to use the control look at, which I don't want. And then I'm simply checking that input pressed variable must be false, and I also need to there's a new UI that I created. That UI must also not be shown currently, because I don't want him to look behind him while I'm trying to customize the character. And then all that happens here is if those conditions are met, it will set the look at alpha to 1. If they're not met, the look at alpha will be 0, meaning it will use whatever head animation comes from the Locomotion animations. But if the look at alpha is 1, then it will use the relative rotation of the camera boom, and then it just simply subtracts 90 from the pitch, from the yaw, and that becomes the yaw. And then it goes to a little clamp function here that just does a bunch of quadrant checks. This is for clamping it so that it doesn't break. And then once those are done, I also invert the, I think I invert the pitch here after clamping it. And the roll is always set to 180 because this is a parent, the parent values that it needs to use, the component parent values. Otherwise it'll actually invert the head and flip it upside down. And then I just simply set that look at rotation. And that's the same look at rotation that gets used by the look at blend, which I covered before. And then that effect there, what it has is, when it detects there's no input pressed, it will follow the rotation of the camera. So you can see the eyes there looking left and right. It's a bit more harder when you're trying to see it, because he's actually following the camera. There you can see the head. The head's moving. And here is just going to be, because I'm providing input, it's not doing that. The next thing I want to show is the character customization HUD. I'll just show a quick demo. And then I'll talk about the 2D blend space. So the character customization UI drives the, you can change the character color, material color, you can change the morph target values as well for these guys. And there's also a randomize function where it will just randomize values, and then you can, once you're done there, it'll actually change the character to look like that. And it includes all his existing animations as well. And if you don't like that, you can always reset it. I just quickly want to show that UI and how it works. So when the UI gets shown, it actually gets called from the character blueprint. There's a function here, show the customized menu. So the character must not be possessed. The character can possess other characters, so you mustn't be currently possessing another character. You can't open up any menus while you're possessing another character. Then it's simply showing this widget, which was created in the begin play event, which is over here somewhere. That's the wrong one. Create player widget. Here's all the widgets get created, and then I just set it as a variable, add it to the viewport. And for this one, I actually don't want to pause the game. So I'm not pausing the game because I want the material and all those things to update. Then I'm calling populate UI on that widget, and that will actually go and look at all the current morph values from the third-person character, get the customization values, and then just simply set the sliders to match. And it will also get the custom color from there. And I'll show how the custom color works as well. There's events that get raised to customize the character or to customize the character color. And when character color is asked to be customized, I use a variable here called, I think it's fish material. Yeah, fish material. If it's not set, this is just a material dynamic reference or whatever, material instance dynamic reference. If it's not set, I just create a dynamic material instance. You also have to tell this function on which index to call it with. This magic number 2 here comes from the skeletal mesh, because this is the material here, 012 element 2 that I want to change, the fish 7 material. And then I use the color from the character custom value, character customization values, break that up use the color there, set it as a vector parameter on the material. And that material, all of those materials had to be changed. They were imported from substance, and I don't want to use the substance variable because it was just it's overkill for just a simple little blend that I'm doing here. I'm just calling a darken on an input parameter called color mix. So what it will do here is set that vector parameter here, color mix, and then override the material, and it does this on every call in the UI. So as these values in the UI change, these sliders all have events tied to them, and as they change, they all call the same function, update customization. And what it does is it actually takes the values from the sliders, creates a new character customization structure, and including the color as well. So there's a new color vector created here, and then that's passed on to the customized character function. So the character customization structure that's created here is set on the character itself, and this variable is defined in the C++ side. This is the structure, and then it's just a little variable here, and then we call this customized character function, which I actually did explain last time. Gets the animation instance tied to this character and calls customized character on the blueprint itself, the animation blueprint, which will set the morph target values. And then a similar thing happens for the color. We just call that customized character color, which then goes and sets that material value, the vector parameter, and then the material. If the dynamic material instance has already been created, it won't create it again. And because we're changing it on the character directly, the changes will remain there until they're changed. And that's where those cameras come in, lerping the camera, changing those values in the in the C++ class of camera boom, offset, length, and all that in the tick event of the character blueprint. We lerp the camera boom here. If it's nearly equal, we stop. This is just a simple float in linear interpolation. But the interpolation for the offset is actually done in C++ and for the yaw. So this one is for the target arm length, the zoom. Okay, then on to the animation 2D blend spaces. So what I did was created a few animations here. One is if he was going to be turning left, I want him to arc to the left. And if he's turning right, I want him to arc to the right. And then I created a new animation for his one of his skills or swim skills, whatever, when he's swimming really fast. That's the swim spread animation. And then I created a .2D blend space. So previously it was using this 1D blend space, which only had one axis here, and that was the speed. So now for the 2D blend space, there's now speed and direction. I've clamped the direction at between minus and positive 30. And then I've dropped these animations in here, so the turn right animation is up here to the right, to the left actually, because the values I think are inverted. and then turn left is on the other side. And down here as well, it's the same one, turn right and turn left over there, and that's on 30 itself. And then direction here starts at idle at 0. Then the swim will start at 60. Swim fast will start at, sorry, the swim will start at 116. Swim fast will start at just under 500, and then the swim spurt will start from 700. So by just sliding these, this preview value here, you can see if you're moving slower and turning, if you're idling and turning, it's not going to do anything. Just what I want. But if he starts swimming a little bit and turning, he's going to start moving or arching toward the angle of rotation. And the faster he swims, the faster that will blend. And then all you had to do in the animation blueprint was pretty simple. I just needed to change the locomotion. The locomotion state here to use that 2D blend space and get the direction. And the direction itself is just a variable defined here in the animation blueprint, and then just set in the animation update itself by just taking the rotation from the actor rotation. This is the world space rotation of this character, the pawn owner, and then taking the velocity from that pawn owner and passing it to this calculate direction function, which is created, which is provided by this animation instance. You pass in the velocity, the base rotation, and then it provides you with a value between negative and positive 180. And then the result of that is, just want to unlock something here. The result of that is, as I turn, I get him arching towards the angle of the rotation. And then if he stops and I rotate, he doesn't do anything. And he can go really fast too. It's still blending. I only did this 2D blend space for the main character. And then if you change his appearance, it will still apply. So the morph targets don't interfere with that. With that 2D blend space. Alright, cool. Also created one more animation. I'm just quickly going to show. You don't really see it a lot. Probably see it more in the AI. It's a little flick animation. That's supposed to be when you're shooting something, I guess. And then I created a montage for that. Animation montage. And this was actually created on all of the characters. And I created a new slot for it as well. I called it the right fin slot. I do have an animation notify here, but I don't actually use it, and I don't think I'm going to. And then all I did after that was I created another pose cache from the upper body blend, which was using the Locomotion cache, because it's doing a blend And now I need to blend again and again and again for different things. So I created the upper body cache, which is now basically a cache of the blend between the locomotion and the upper body. And then I just did another layered blend per bone, and in this case I'm looking for only the right upper arm, nothing else. And I'm using the cache then with that right fin slot, and that becomes the final pose. And that plays, and the animation montage itself plays. I actually played this from third-person character blueprint on the shoot event. It's up here somewhere. Here we go, the shoot. The shoot event is called when you fire, and everything is unlocked and all that stuff. And when it starts off, only through the main character, the main player character, I get the animation instance, the correct one for this character, and then I just simply call montage play. And I'm actually calling this from the character blueprint, not from the animation blueprint. I'm passing it in that montage. So if I just unlock shooting here, you can't really see the animation because you'll be in a more of a first person kind of view. But if you do shoot, you can see from the shadow there, it's flicking. Okay, cool. I think that wraps it up. Thank you.